section 6 of relations and functions. In the last section, we discussed different type of functions like one-one functions, on-to functions. In this section, we are going to study about bijective functions. Bijective. So first I will tell about its definition. A function f from a to b is called bijective if it is both one-one and onto. It should be one-one and onto. Then we can say that that function is a bijective function. I'll give one example. Now, take one set A and the set B. Suppose A consists of 3 elements and B consists of 3 elements x, y, z. Suppose 1 is related to y and 2 related to x and 3 related to z. Is it a bijective function? It should be both 1-1 and 1-2. Is it a 1-1 function? It is 1-1, but because if you take any two different elements, then that elements are having different images. So it is 1-1 function clearly. Is it onto? Every elements in B are having 3 images. Otherwise, what is range? Range equal to x, y, z. Range equal to set x, y, z. That is equal to codomain. Since range is equal to codomain, we can say that function is onto and it is also a 1-1 function. So it is 1-1 and onto, hence it is a bijective function. Here you have to note on one thing. A function f from a to b is bijective if number of elements in A is equal to number of elements in B. This is one condition. Suppose if number of elements in A is not equal to number of elements in B, then we cannot form a bijective function from A to B. For example, suppose A consists of, B, 2 sets, A consists of 3 elements and B consists of 2 elements. Here, number of elements in A is more than number of elements in B. Can we form a bijective function from A to B? So, it should be 1-1. So, I am relating 1 with x, 2 with y. Then, 3 I have to relate with any of these two elements. Otherwise, it will not be a function. So, I have to relate 3 with y or 3 with x. Then, it will not be a 1-1 function because 2 and 3 are having same image. So, if number of elements in A is more than number of elements in B, then we cannot form a bijective function. Same way, if number of elements in A is less than number of elements in B, then also we cannot form a bijective function. Suppose A consists of 2 elements x, y, B consists of 3 elements. One is related with x is related with 1, y with 3. This is 1-1, okay, because x and y are different and the images are different. Image of x equal to 1, image of y equal to 3. What about onto? It is not onto because 2 does not have any pre-image. So, if number of elements in A is not equal to number of elements in B, we cannot form a bijective functions. So, you have to note down one thing. If f from A to B is bijective, then n of A is equal to n of B. Now, I think the concept of bijective is clear. It should be both 1-1 and onto. Okay. Now, we can do some questions. First question. Let f from R to R be a function defined as f of x equal to 13x minus 5. Show that f is bijective. Question is show that f is bijective. That means we have to show that it is 1-1 and onto. So 1-1. We can prove 1-1 by general method. So let x1, x2 belongs to domain, that is R, such that f of x1 equal to f of x2. F of x equal to 13x minus 5. So f of x1 will be 13x1 minus 5 and f of x2 will be 13x2 minus 5. So we can cancel minus 5 from both sides. So we will get 13x1 equal to 13x2 So we'll get x1 equal to x2. So it is clearly a 1-1 function. Now you have to go for onto. Onto also we can prove by general method. So you have to take one element of codomain. Let y belongs to R. Your codomain is R. Such that f of x equal to y. For every y, we have to find one x. F of x equal to y means 13x minus 5 equal to y. So what is value of x? It will be equal to y plus 5 by 30. Now you have to check whether this x belongs to domain or not. Y is a real number. So y plus 5 will be a real number. Real number by 13 is another real number. That means x belongs to R. So for every y belongs to R, we can find one x belongs to domain. Now you have to show that image of x equal to y. For that, you have to find f of x. F of x means f of y plus 5 by 13. This one you have to substitute in the formula. F of x equal to 13x minus 5. In place of x, we have to write y plus 5 by 13. So we'll get 13 into y plus 5 by 13 minus 5. Minus 5. So I can cancel 13. This will be equal to y plus 5 minus 5. That means 1. So for every y, we can find one x. Its image is equal to y. So function is onto and it is 1-1 also. So since it is 1-1 and onto, we can say that function is a bijective function. Okay. Now consider second question. Show that f from q minus set 3, that means domain means all rational numbers except 3, to q defined by f of x equal to 2x plus 3 by x minus 3 is not bijective. We want to show that it is not bijective. That means it may not be 1-1 or it may not be onto. For showing it is not 1-1 or not onto, one example is enough. So anyway, we will go for 1-1 first. 1-1. Let x1, x2 belongs to domain, that is q minus set 3. That means x1 and x2 are not equal to 3, such that f of x1 equal to f of x2. So first, if x1, x2 equal to 3 means this function is not defined. That means because f of 3 will be 6 plus 3 by 0. That is why domain is q minus set 3. Okay. So let x1, x2 belongs to q minus set 3 such that f of x1 equal to f of x2. So f of x equal to 2x plus 3 by x minus 3. So f of x1 will be 2x1 plus 3 by x1 minus 3 will get, and f of x2 will be 2x2 plus 3 by x2 minus 3. Now we cannot cancel 3 from right hand side. So that is wrong method. So you have to cross multiply. So 2x1 plus 3 into x2 minus 3 is equal to 2x2 plus 3 into x1 minus 3. Now we can expand this one. So we'll get 2x1 x2 minus 6x1 plus 3x2 minus 9 is equal to right hand side 2x1 x2 minus 6x2 plus 3x1 minus 9 you will get. So you can cancel 2x1 from both sides, minus 9 from both sides. Now you have to take all similar elements to one side. So minus 6x1 plus 3x1 we can take left hand side. So minus 6x1 minus 3x1 we will get minus 9x1 on left hand side. Right hand side minus 6x2 already it is here. Now take this plus 3x2 to right hand side. So we will get minus 3x2 minus 6x2, that is minus 9x2. Minus 9x1 equal to minus 9x2, which implies x1, which implies x1 equal to x2. So function is clearly 1, 1. That means this function is not onto. You have to verify. Onto. So first we will go general way. So let y belongs to codomain such that f of x equal to y. F of x means 2x plus 3 by x minus 3 equal to y. So remaining I will write here. This you have to cross multiply. So you will get 2x plus 3 is equal to y into x minus 3. Right. So 2x plus 3 equal to yx minus 3y. Now here there is one important step. After this step you have to take all elements containing x to one side. Then only we can express y in terms of x. So 2x minus yx is equal to minus 3 minus 3y you will get. Take x from these two terms. X into 2 minus y is equal to minus of 3 plus 3y. We can write like that. So what is the value of x? That is minus of 3 plus 3y by 2 minus y. For every y belongs to Q, we are able to find one x. Now we have to check this x belongs to, x always belongs to domain or not. Always you have to consider denominator. When y equal to x is not defined, that means 2 does not have any preimage. That example you have to find. When y equal to 2, what is the value of x? X equal to minus of 3 plus 6, 3 into 2 by 0, which does not belongs to q minus 3. When y equal to x is not defined, otherwise x does not belongs to q minus 3. That means 2 does not have any preimage. So function is not onto. So we can say that 2 does not have any preimage, therefore it is not onto. Okay. Now consider third question. Let f from R to R defined by f of x equal to x square plus 1. Show that f is not bijective. Here also you have to show that it is not bijective. That means it may not be 1, 1 or onto. So first we will go for 1, 1. Let x1, x2 belongs to domain. Domain is R such that f of x1 equal to f of x2. So f of x equal to x square plus 1. So f of x1 will be x1 square plus 1 will get, and f of x2 x2 square plus 1. So we can cancel 1 from both sides. So we'll get x1 square equal to x2 square. So x1 equal to plus or minus x2. Here both value we can take. Minus value and plus value we can take because domain is R. That means this is not 1, 1. But you have to find one example. Okay. Minus 1. Clearly minus 1 is not equal to 1. But f of minus 1 is equal to minus 1 square plus 1. That is equal to, and what about f of 1? F of 1 will be 1 square plus 1 is equal to 2. Means two different elements are having same image. So it is not one function. That means we need not go for onto. Since it is not 1, 1, we can say that it is not bijective. Okay. Now consider fourth question. Let f from n to n defined by f of x equal to, this is one important question, f of x equal to x plus 1 by 2 when x is odd, equal to x by 2 when x is even. I will read once again. F of x equal to x plus 1 by 2 when x is odd, equal to x by 2 when x is even. So when value of x is even, we have to use this definition. For example, when x equal to 4, suppose we want to find f of 4. F of 4 will be 4 by 2, that is 2. What about f of 5? F of 5 will be, if 5 is odd number, so you have to use first definition. That will be 5 plus 1 by 2, 6 by 2, 3. Like that you have to find. State whether f is bijective or not. State whether f is bijective or not. That means you have to check whether it is 1 1 and 1 2. So first we can go for 1 1. So 1 1. Here you have to consider different cases. This is a special question. x1 x2 belongs to domain. Both x1 x2 can be odd. Both x1 x2 can be even. 1 x1 odd, x2 even, x2 odd, x1 even. Like that, 4 different cases you have to consider in this question. So case 1. Case 1. Let x1 x2 odd such that f of x1 equal to f of x2. Since x1, x2 are odd, what about f of x1? You have to use that first definition. F of x1 will be x1 plus 1 by 2. And f of x2 will be x2 plus 1 by 2. So you can cancel 2 from denominator. So x1 plus 1 equal to x2 plus 1 means x1 equal to x2 will get. Now case 2. Case 2. x1, x2 are even. x1, x2 are even. So such that f of x1 equal to f of x2. Since x1 is even, you have to use second definition. F of x equal to x by 2. So f of x1 will be x1 by 2 equal to f of x2, x2 by 2. So clearly x1 is equal to x2. So 2 cases are okay. Now you have to go for third case. Third case means x1 odd, x2 even, such that f of x1 equal to f of x2. F of x1 will be, since x1 is odd, f of x1 will be x1 plus 1 by 2. Right, first definition you have to use. And since x2 is even, f of x2 will be x2 by 2. You can cancel denominator. So we will get x1 plus 1 equal to x2. So what about your conclusion? x1 equal to x2 or x1 not equal to x2? Clearly, x1 is not equal to x2. But you have to consider one thing. This condition should be a possible condition. It should be true. Then only we can consider x1 not equal to x2. Now, check whether this is true or false. x1 odd number plus 1 equal to even. Left hand side is one even number, right also an even number. So we can equate, no problem. So this equation is true. This one is possible. So we can consider this case. So function is 1 1 or not 1 1. Function is clearly not 1 1. If it was 1 1, f of x1 equal to f of x2 implies we will get x1 equal to x2. Here we are getting x1 is not equal to x2. So function is clearly not 1 1. Same way, fourth case also. Case 4 is x1 even, x2 odd. In that case also we will get x1 not equal to x2. Actually we need not go for fourth case because we already got x1 not equal to x2. So it is not 1 1. If it is okay here, then you have to go for fourth case also. Anyway, if you want, you can do. So x1 even, x2 odd, such that f of x1 equal to f of x2. So we will get f of x on x1 even. So f of x1 will be x1 by 2 and x2 odd. So f of x2 will be x2 plus 1 by 2. That means we will get x1 equal to x2 plus 1. Clearly x1 is not equal to x2 and this is a true case because x2 is odd number plus 1 will be always an even number because x1 is even. Okay. So what is our conclusion? Function is 1 1 or not 1 1. It is clearly not 1 1 by case 3 and case 4. Very important question for board examination. Now we can consider one more question. F from W to W be defined by f of x equal to x minus 1 when x is odd equal to x plus 1 when x is even. Show that f is bijective. That means it is 1 1 and 1 2. This question you have to compare with last question. So we can go for 1 1 first. 1 1. Just like last question, 4 different cases you have to consider. x1, x2, odd, such that f of x1 equal to f of x2. So since x1 and x2 are odd, we have to use first definition. So it will be x1 minus 1 is equal to x2 minus 1. You can cancel minus 1 from both sides. So you get x1 equal to x2. So case 1 is okay for 1 1. Now case 2. x1, x2 even. Both x1 x2 are even, such that f of x1 equal to f of x2. So since x1 and x2 are even, you have to go for second definition. That means f of x1 will be x1 plus 1 and f of x2 will be x2 plus 1. So clearly x1 is equal to x2. So just like last question, case 1 and case 2 are okay. Now you have to go for third case. Third case, x1 odd, x2 even. x1 odd, x2 even. f of x1 equal to f of x2. Since x1 is odd, first definition, that means x1 minus 1, x2 even, you have to take second definition, that is x2 plus 1, which means x1 equal to x2 plus 2. x1 equal to x2 plus 2. Clearly, x1 is not equal to x2. But what about this equation? Is it true or is it possible? Take left hand side. Left hand side is x1, that is an odd number. What about right hand side? x2 even number plus 2. Even number plus 2 is always an even number. So right hand side is even number, left hand side is odd number. This is not possible. In last question it was like this. x1 equal to x2 plus 1. We got like that. So odd number plus 1 is even. Left hand side is even. So this equation was possible in that case. Here it is not possible. That means we cannot consider x1 not equal to x2 because it's impossible case. So we cannot consider case 3. So we have to write like this. Since x1 equal to x2 plus 1, x2 plus 2, not possible. Not possible. You have to stop here. Now case 4 also we can check. Case 4. x1 even, x2 odd, such that f of x1 equal to f of x2. Since x1 is even, f of x1 will be x1 plus 1. Since x2 odd, f of x2 will be x2 minus 1. That means x1 plus 2, we will get x2. This is also impossible because odd number, no, x1 is even number plus 2, left hand side is even, right hand side odd, even number equal to odd number, not possible. We cannot consider this case also. So case 3 and case 4 we cannot consider because case 3 and case 4 here we are getting not possible. So in last question it was possible, so we have to consider case 3 and case 4. In this case, it is not possible here. So we cannot consider case 3 and case 4. Therefore, by considering case 1 and case 2, we have to say that function is 1 1. Clear? Very important question. This question you have to compare with last question. So last question it was not 1 1. In this case, this one is 1 1. Okay. Now we can verify whether it is onto or not. So let y belongs to w such that f of x equal to y. Here also you have to consider two cases. X can be odd or even. So first case, x odd. When x is odd, f of x equal to y implies x minus 1 equal to y. Right? When x is odd, f of x equal to x minus 1. So what is the value of x? X equal to y plus 1. Now we want to show that image of x equal to y. So for that we have to find f of x. F of x means f of y plus 1. Now x is odd. That means y plus 1 is odd. So this term is odd. If x is odd, we have to go for first definition. So y plus 1 is odd. That means you have to go for first definition. Is equal to, in place of x, you have to substitute y plus 1. So it will be y plus 1 minus 1. That is y. So for every y, we can find one x. Its image is equal to y when x is odd. So case 1 is okay for on 2. Now we have to check whether it is okay for case 2. So when x even, then f of x equal to y implies x plus 1 equal to y, because when x is even, f of x equal to x plus 1. So value of x equal to y minus 1. Now you have to show that image of x equal to y. So for that, find f of x. F of x means f of y by f of y minus 1. Now x is even, x equal to y minus 1 means y minus 1 is even. If this term is even, you have to use second definition. In place of x, you have to substitute y minus 1. So we will get y minus 1 plus 1 equal to y. So for every y belongs to w, here also we can find one x such that f of x equal to y. So case 2 also okay for on 2. Therefore by case 1 and case 2, we can say that function is on 2. So since it is 1, 1 and on 2, it is a bijective function. This question is very important question. This one you have to compare with our last question. Okay. So these are some important questions from bijective section. In the next class, we will study how to find inverse of a function. So thank you. All the best.